Now let's explore the latest version of Bash, which is 3.x, that is included with most Linux and Unix distributions nowadays. When we began our studies, we focused on Bash 2.x, which was at the time included with most Linux and Unix distributions. Now, not much has changed over the years with Bash, but it's still good for us to compare and contrast whatever differences may exist, if any. So let's authenticate. We'll take a brief look at the architecture that we're working with. We have a drawing here from our SFTP edition. Let's take a look at this drawing. This is the layout that we'll be using to work with throughout our studies. Two switches interconnect the various hosts. We've got a MacBook connected to the internal switch, the primary internal switch, Solaris 10, SUSE Enterprise 11, Red Hat Enterprise 5, Windows 2008, and FreeBSD. For this particular series, we'll take a look at the Solaris SLES 11, Red Hat Enterprise 5, and Mac OS 10 boxes. So these are the systems all interconnected onto the 192.168.75.0 or 75.x subnet. They all run some version of Windows, Linux, or Unix, or Mac OS 10, and all but the Windows 2008 system support by default Bash. Let's open a shell. And on this box we'll cat etc Red Hat-release. That's how you tell the version of Red Hat that you're running on a given system. This is 5.4, currently the latest available in early 2010 from Red Hat. Now, to determine the version of Bash that's running on this system, there are a number of things we can do. We can echo the shell, which is a variable, if you recall, that we discussed before, that's maintained per shell. This tells you which shell that you're running in this particular window for this particular pseudo terminal, which happens to be pseudo terminal number 1. So indeed we are running Bash, but it doesn't tell us the version. There's another variable named bash_version. If we do a set grep uppercase bash, since the variables are set with uppercase names, we'll see that there's a variable named bash_version, and that indeed it's running the 3.x release of Bash. So echoing simply bash_version tells you the version of Bash that you're running on any of these Nix-based systems. Now let's launch a gedit session to update some notes, which are included in the documentation directory. So in this particular section, we're basically exploring and comparing / contrasting Bash 2.x with 3.x. By and large, they're the same. There are very few differences between them. So, as a task, we wanted to determine the running version of Bash on all systems. And in order to do so, we decided to execute echo bash_version. Alternatively, you could run, for example, set grep bash, and this would return all variables prefixed or containing uppercase BASH, and then you'd see that bash_version is a variable that you could reference. Now let's confirm that bash_version is a variable that's available on all interested Nix-based systems. So this is our Red Hat Enterprise 5 box. Let's take a look as a separate task or a subtask. Confirm Bash versions on additional systems. And before doing so, let's save this document. So we'll call this bash updates notes.txt, and we'll append to this document anything we update to the product over time. So you can consult this particular document regardless of which version of Linux CBT Bash Edition you pick up. So in a separate window, Control-Shift-T will give us a new window. We can connect to the other systems. Let's SSH to the SUSE Enterprise 11 box. By the way, let's just look at the drawing so that we know that what we're connecting to. The SUSE Enterprise 11 box is this system here that the mouse is currently over. Its IP is 7550, so we'll connect to 7550. And it prompts us for authentication. And now we're on. So on this system, if we cat etc SUSE release, we see it's running version 11, the default patch level, or the initial release. And similarly, if we echo bash_version, it releases, or it reveals that it's running 3.2.48, comparing and contrasting to the Red Hat Enterprise box, which is running 3.2.25. And this is because SUSE Enterprise 11 was released after Red Hat Enterprise 5.4. So the SUSE release just happens to have a slightly newer version, but still the same main 3.2 code branch. So it's running 3.2 as well. Let's confirm over on Mac OS X as well, using another window. And we have a box located at .26. Let's take a look at the drawing just to confirm. It's actually DHCP, but it currently is running at .26. If we execute an nmap against the host, let's see if we've got nmap running. We don't. Let's check on the SUSE Enterprise 11 box. We should have it running there. This should return that port 22 is open, which is the SSH port, so we should be able to connect and obtain a pseudo terminal. So let's SSH as the user Dean to that remote system. And in fact, there's a user Linux CBT we can use. So we'll use that user instead. And this will come back momentarily, prompting us to connect. And in the interim, let's launch a separate shell to our Solaris box. Which is located at 150. It prompts accordingly. And this is probably because it doesn't allow root to log in by default. So let's try to log in as a different user. And here we have public key authentication set up, so it lets us in directly. Let's see what's going on with the Mac OS X box. It still hasn't responded. Check our IP address. It looks correct, so we'll get back to that momentarily after we confirm the bash version on the Solaris 10 instance, which is taking a little time to return its shell. Now once the versions have been confirmed, we'll just test some basic features of the bash shell, including redirection pipes, perhaps run a for loop, update the prompt, basics, just to be sure that what you've expected from bash 2.x, or what you're comfortable with from the older version, still applies to the newer version. Now this shell is still taking a while. What we'll do is try to make these connections from the SUSE Enterprise 11 box, since apparently the network I/O between the Red Hat Enterprise and the Mac OS and Solaris boxes is restricted, perhaps by firewall. So in the interim, without having to debug those issues, let's try to SSH into the Mac OS X box. Since we know the port 22 is open, we'll SSH as the user Linux CBT, and that comes back nicely. And now we're on. This is the Mac OS X box. It's in fact my MacBook. Let's echo bash_version. This is running 3248, same release as SUSE Enterprise 11. We can scroll up to confirm that in our dump if it's still there, and it appears to be. And there it is, 3248. So both Mac OS X, Snow Leopard, and SUSE Enterprise 11 are running the same version of Bash. Let's open a new window. We'll SSH to the SUSE box, since it is not restricted currently. And then SSH to the Solaris box as the user Linux CBT. And there we have a session. Let's echo bash underscore version, and indeed it's running 3.00. This particular release of Solaris 10 is from 2009, so perhaps the subsequent release will include a later version, but that's neither here nor there. So we have multiple windows open: Mac OS X, Solaris 10, Red Hat Enterprise 5. 3 boxes where we can test basic Bash skills. So let's look at, for example, redirection as task number 2. Test redirection. If you recall from earlier on in our studies, redirection is the ability to move data in and out, as well as optionally to append. So, a simple example of redirection is the ability of a process to take as its input a text file. For example, most processes such as ls, grep, etc. automatically take input without you having to specify the less than input redirection. So, one form of redirection is input redirection, supported by default by most, if not all, processes, because processes expect input, at least some form of input, in order to operate, whether that input be parameters, a configuration file, one or more, or some other options that are indicated on the command line. Processes expect input. Now, what the process does with the output is a separate issue altogether. So input redirection, for example, when we decide to grep, let's say from a text file, let's find a text file here on our directory. Here we've got a file 1000.txt. So when we decide to grep from the file the number 500 from 1000.txt, the grep process expects as its input the file named 1000.txt. That's input redirection. And it greps, it finds a number in the file accordingly. Optionally, you may indicate input redirection, and it's read in the same way. This is optional, which means you don't have to specify it. So input redirection works just the same as it did in the older version of Bash. We could find a similar file on the Solaris side, grep input redirection. We want to grep something from it, the number 500 from perhaps the file 10million.txt. And we'll wait for this to come back. And as it does, let's take a look over on the Mac OS X side. Let's grep the number 500 using input redirection from 10mil1.txt. And wherever it finds 500, it returns it. And optionally, if we disable the explicit indication of the less than symbol, it works similarly. So input redirection works the same way, and expect output redirection to work the same way. The Solaris instance still isn't responded. This instance happens to be a VMware instance which could be competing for resources, which explains why it's so slow. But that's besides the point. That's not important at this stage. So input redirection works the same as it does in the old version of Bash. Similarly, output redirection works similarly. Output redirection allows you to send the output of a process to a file or to some other location other than standard out. So for example, on our Red Hat Enterprise box, we could grep 500 from 1000.txt, and the default location to send the output is to the screen or to standard out. That's the default location. However, we could send that output to somewhere else, such as a file. So let's grep 500 from the file, sending it to grep test.txt. So now instead of the output being written to the screen, which is file descriptor number 1, it sends it to the file grep test.txt. Now, with the new version of Bash, we can confirm the exit status as should be expected using echo ? If a process has run successfully, then the output should, or exit status should, return 0. In this case, it has returned 0, so it has run successfully. Let's cat the contents of grep test.txt, and there it is. So the output has been redirected from standard out, file descriptor 1, to the text file that we've indicated. So permits the influence or redirection of output from stdout to desired file, which can also be an alternate location such as to a socket, to a name pipe, or some other location which is still represented by Unix and Linux as a file. So output redirection, input redirection, append redirection, these are all things that work as expected. And the Solaris instance still isn't responding. So on the MacBook, for example, we can grep 500, sending it to grep test.txt, and then echo the exit status because it's running Bash, and it's still clean. So input, output, and append redirection. Let's cat the contents of grep test.txt on the MacBook, and there it is. Now we can append to it using append redirection. So let's grep, for example, 600 using append redirection into grep test.txt, and then cat the contents of grep test.txt, where we should see references to 600 terminating the document. So all of these things still work with the new version of Bash. There are small under the hood differences. So what you've studied from our earlier release or the initial release of Bash entirely applies to the latest release. Just tiny things have been changed over the years. But Bash is Bash. The shells don't change overnight. They're the same by and large. How about some other semantics, some other features, like piping, for example? So if you want to combine the activities of processes, for example, we can cat the contents of grep test, piping its output into some other process, let's say awk, which will then print field number 1. Piping works as expected. You can take this command and run it on any of the platforms that include both, or include cat as well as awk, and expect it to run similarly. So for example, let's do a which awk on the Mac side. It's available. Which grep, which cat, grep, and awk are available. That means we can paste the command and expect it to run accordingly. It's printed field number 1. How about printing field number 2? It prints an empty or white space per line as expected. So piping works the same way. How about for loops? The ability to loop through documents, outputting or dumping to the screen or to some other location, perhaps if used in conjunction with redirection, the contents of the document. Well, the for loop loops through, and for each iteration allows you to take advantage of each of the entries. So for example, let's take a look at one of our text file documents here, like 1000.txt. This document contains the numbers 1 through 1000 towards the end. Head and tail would tell us that as well. We could use a for loop defining a variable, and let's just list this as another task. For loop, so test for loop invocation, and expect it to work similarly. So for I in, and whatever that command is, we're using command substitution here, which also works. So we could cat the contents, let's say, of 1000.txt. So what will happen here is, for each record or each line found in a 1000.txt file, for that instance in time, the line or the record will be assigned to the variable I, which we can then use in our shell. So for I in cat the contents of 1000.txt, let's just do something simple such as echoing what we've captured on a per record or per line basis, and it behaves just like cat. So in essence, the for loop does exactly what you've expected, which is to loop through the contents of the document, dumping it to the screen. But then we could do other things, such as on a record by record basis, awk, let's say, the contents of it, printing whatever fields are of importance, let's say field number 2. So for each line, awk the contents of it, but it needs to be echoed into it, so we need to echo I one at a time, piping it into awk, and there you see awk attempts to print the second field all the way through the last line, and will break it along its way. There is no field number 2. Echoing I echoes one field, but if we instructed awk that the field delimiter is something such as a number or no space, then it would treat or break up each of the characters accordingly. So these are some of the things you can do with the for loop, and it works in Bash 3.x as well. Let's check on the Mac OS X side, and let's find our text file. That's the 10million.txt. Let's alter this. So for I in cat the contents of 10mil1.txt, do echo I, done. And just like using cat, it'll dump the contents of this document one record at a time. And let's just double check that. And this is a big document, so the syntax, we've broken it. So for I in cat the contents of do echo I, and this will attempt to rip through the contents of 10mil1.txt, echoing one line at a time through the iteration of the cycle. Now let's take a look at our other host to see, compare and contrast. For I in cat the contents, let's just check our syntax, make sure, and there it is, it's running. It just took a while to get through the 10 million records. And again, we could then use awk or some other process to split this up and return individual numbers if we so chose. So what are some of the other things that we could do with our new Bash environment? For example, we can change the prompt. We know that redirection, pipes, looping, all of the typical things or features of the shell are the same by and large. So what about manipulating the prompt? We'll set it up as another task. Manipulate prompt on various platforms, and we'll again try to connect to the Solaris box to see if it's more responsive this time around. Now, in order to update the shell, we must influence the PS1 variable. So in order to do so somewhere, whether it's at the shell or via the bash configuration file, hidden bash underscore profile or bash underscore RC, we need to indicate the export of the PS1 variable. And this variable needs to be set to various things that are of interest to us. So let's wrap the whole command with double quotes indicating the single quotes in between that will indicate either on the command line or in the config file. So PS1 is a prompt variable. This is a variable that influences what your prompt looks like. So here on the Mac OS X box, let's echo the contents of PS1, for example. Here we see PS1 includes H for the host name, the short name of the host name, and that's an uppercase W, which prints the working directory, the user, and it terminates apparently with $. So this prompt is the default Mac OS X bash prompt string, in between single quotes, of course. Now, no need to memorize these variables. Just do a man bash and you'll see a section in the manual page or manual that's reserved for the variables that are supported for the prompt. Again, the H is simply for host name, and this is the short host name, which means it's not the FQDN. The W is the working directory, and this is uppercase W. There are two ways of doing it, by the way. If you do a man bash, let's pull this up, scroll through towards the section where the variables are listed, and we will be there momentarily. Bash is fully featured, supporting branching, looping, various things. And let's see what we've got here. This is not the section. And we need to go deeper into the document to come up with these variables. And you'll see the subtle differences between upper and lowercase w as an example. And we just passed the file descriptor section, and this is definitely buried in the documentation. Perhaps using the HTML version would make it easier. That's the testing section. All of that remains intact. Your ability to test whether or not files are empty or contain other content is still intact. Job control is still intact. And finally, here are the variables. So lower h, hostname, minus the remainder of the FQDN. Upper H is the full host name, which is the FQDN. Scroll down. Upper W is the base name of the current working directory, whereas lower W is the current working directory. So this directory that we see here, Linux CBT, is the base name. It's not the full directory. The base name meaning just the important part of it, or the name of the directory that you're currently in, sans the prefix /users forward, or wherever you happen to be within the directory tree. So to influence this prompt, let's say we want to change it to perhaps include the host name, the full working directory, and maybe maybe username at the host name, full working directory, the way it's typically represented on Linux systems. We would include a PS1 export which resembles the following: escape \u, @ symbol. You don't want to escape the @ symbol because then that will reference the time. Escape the hostname, escape the full working directory, and perhaps terminate with a $, since that is what the Mac OS X prompt defaults to. Copy this string, and then at the shell just paste it, and then the prompt will be updated. We should terminate with a single quote. That will definitely help matters. And now we see that our prompt has been updated accordingly. So we've gone from host name, short name or base name of the current working directory, to username at host name and the full working directory. Now, the tilde represents the full working directory. Tilde means home in Unix and Linux convention, so that's understood. But if you navigate it to a different directory like the root, notice it updates. Then navigate into users, it updates, and then into Linux CBT it's simply changed into tilde. Now this is the prompt that's available on Linux, so there's no need to update the Linux system. But the Solaris system, for example, uses a different prompt. Notice it doesn't include any of the variables, but because it's bash, it supports those variables. So what we need to do is perform a similar export. Let's paste. Finally, it gave up on that file. It didn't actually die. Single quote, and now we have a prompt which reflects the user at the short host name, followed by the working directory, followed by a $, and as we move around, let's say into export home, the prompt is updated accordingly. Now, of course, to make this prompt persist across the board, we need to store it in a bash configuration file, preferably in the user's home directory. So let's just ensure that we update the user's config file. We'll nano bash underscore profile. This is one of the files that you may use. You may also do bash rc, and we'll paste the prompt export here, terminating it with a single quote, and that's enough to effect the change. And we can include a comment, updated prompt, to include user at, or perhaps user at hosts colon pwd, or working directory terminated by a $. So basically this is what the prompt will look like. Let's save the changes, and if we exit and then reconnect, and notice the SUSE prompt simply includes the host name, not the user at the host name, so we could update it if we'd like. Let's SSH back into the Mac OS 10 box, and now we see the prompt has been updated because bash 3.x, just like 2.x, reads the user's home directory in search of a hidden file, bash underscore profile, or any bash related file, bash underscore history, where it stores a history, bash rc, all hidden files read by bash across the board. So now the prompt's updated as we'd like. Let's update the prompt on the SUSE box. We'll modify that user's bash underscore profile, pasting in a similar, and since this is for the root user, we'll stick with the convention of terminating with a hash mark. Save the changes. Now to see these changes affected on the fly, you could use source or dot space bash underscore profile. This will cause the bash shell, the currently running shell, to read this particular file. Now notice that the hash mark was misinterpolated, so let's nano that file again, and that's because it includes a backslash. It should simply be hash mark, perhaps with a space. Let's save the changes and source it again. You could use the built-in bash command source, or simply a dot, and now we get the hash mark. Perhaps you want to terminate it with a greater than sign, so on and so forth. So now we see user at host name, and this will persist across the board. If you want it to persist for all users, then update the etc version of bash profile, either the profile file itself or any of the bash related files like bash.bashrc. Profile is also read, so that's usually a good place to place those items. Similarly for the Sunbox, you'd need an editor such as Nano if it's available, or VI, and navigate into the user's home directory, which is in export home, VI bash profile, paste the prompt, I to insert, terminate it with a single quote, and then escape, and then source the file, or log off, and then log back in. And notice that this shell for the SUSE box didn't reread on the fly, or didn't read on the fly the bash underscore profile file. Let's just prove that it does by relogging in. and you'll see that the prompt will be updated momentarily to be user at hostname plus the working directory. So now let's re-SSH into the Solaris box, and we want to connect as a user Linux CBT. We're prompted, and now we see the prompt has been set accordingly. So as you can see, these things work just like they have in the other version of Bash that we've studied thus far. This is one of the reasons why we haven't updated Linux CBT Bash Edition and other products like Perl, Python, PHP, because the semantics are the same over the years. These things simply don't change overnight. So this is a little bit about Bash updates as they apply to the newest version of Bash that you may find on various distributions.